For part two of the lecture today, we're going to go ahead and still use the Terre Haute to Evansville problem that we just used. We're going to use the same winds aloft, those 270 at 10 knots. We're going to use the same true airspeed of 120. But what we're going to do is we're going to have to break this particular single leg route down to two legs. So let's just say for whatever reason we can't go straight from point A to point B on that course that we just calculated. So we're going to go ahead and say that, let's say there's some sort of pop-up TFR right here near Bruceville that's going to get into our way. So we need to add a different checkpoint in there, another leg, if you will, of this flight to safely navigate around that particular obstacle, or whatever reason we can't go direct. So for our purposes here, we'll just go ahead and say that we're going to add a navigation checkpoint, which is going to be, we'll go ahead and use KLWV. We'll use the Lawrenceville Airport for an intermediate checkpoint. We'll go ahead and break it down and do those calculations based off of that checkpoint being added. The calculations are going to be roughly the same. You'll still use the same general equation that I gave you. We'll just have to run those numbers twice, and we'll come up with different numbers, and then we'll have to add the two together and complete the calculations accordingly. So just like before, our first step is to connect those 2 points, in this case Terre Haute with Lawrenceville Airport with our plotter. We can go ahead and draw a straight line along the straight edge, and then we're going to go ahead and determine the total distance from Terre Haute down to Lawrenceville. Again, using the sectional scale for a mileage chart, we come down and we determine that our distance from Terre Haute to the Lawrenceville Airport is going to be 44 nautical miles. So let's take that information and bring it over here to our sheet. Now, a lot of times you're doing multiple legs. It's useful to break it down into leg 1 and leg 2. That way you can keep your math separate and you add everything together at the end. So we got our leg 1 distance, like I said, we just determined, was going to be 44 nautical miles. Coming back over to our plotter, we're going to reference the course. So again, we're going to take a rotating bezel. We're going to line it up with this particular line of latitude right here. And then we're going to go ahead and take a look underneath our true course arrow there, which gives us a true course for that first leg of approximately 200. So we'll plug that into our equation right up here. Now we got our total distance and our fuel for the first leg. Now we need to come up with the distance and the course for the second leg. So again, we place our plotter in between Lawrenceville and Evansville, and we can use our scale to determine what the actual distance is. So using Lawrenceville as the reference, coming down along our scale, we can see that our total distance from Lawrenceville to Evansville is going to be another 44 nautical miles. So we'll go ahead and park that in our slot we drew over here for our leg 2 distance. And now we'll come up with our leg 2 true course. Doing it just like we did on the last one, we line up our lines until they're about parallel with those lines of latitude. We read it under the true course line. We can see in this case our true course for Lawrenceville to Evansville is going to be approximately 175. So we'll go ahead and we'll plug that into our equation here for the leg 2 true course. For these two legs here, we're going to go ahead and use the same winds and true airspeed we used for the previous one. So our winds are still going to be 270 at 10, and our true airspeed is still going to be 120 knots. So now we're just going to spin the winds for each individual leg. Again, with the wind dot, I have the true index over 270, and I have my wind dot there at a 10 knot reference. So we determined that our first true course we said was 200. So we'll set that under our true index like so. And then we need to go ahead and slide our wind dot up until it's touching that true airspeed of 120 knots. And then from there, we'll get a wind correction angle. All right, we can see here we're looking at approximately 4 to the right. So for leg 1, we're going to say our wind correction angle is going to be 4 to the right. And we'll read our ground speed for leg 1 under that grommet, which we can see in this case is going to be approximately 100 and we'll call it 16 knots ground speed. So we'll go ahead and fill that part in there as well. All right, now we don't have to do anything different with our wind dot here. We just have to go ahead and spin in our second true course, which is going to be a 175. And again, we'll slide that wind dot up to that 120. So there it is on 120. We can say that our wind correction angle is going to be closer to 5 to the right. So in that case, we'll go ahead and say 5 degrees to the right. And with our grommet, we'll go and determine that our ground speed for that second leg is basically still going to be 120 knots across the ground. With that information, we can go ahead and finish working through our course calculation there and our heading calculations. And then with that ground speed and the distances, we can go ahead and start working through our time and fuel. So walking through the math again here, we have our initial true course of 200, and we're adding that 4-degree wind correction angle because it is to the right, which gives us a true heading of approximately 204. All right. Now we still have the magnetic variation based off of our isogonic lines. We're still looking at that 4 degrees to the west, so that'll still be another additive factor. So what's going to compensate for the magnetic variation? We're going to get ourselves a magnetic heading of approximately 208. Again, assuming the deviation is going to be 0. So our compass heading for that first leg, we're looking at 208. Now we already have information to figure out the compass heading for the second leg. So we'll apply that wind correction angle to the true course. So we can see that 175 plus 5 is going to give us a true heading of 180. There's our 4 degrees west magnetic variation, which is going to give us a magnetic heading of 184. Again, 0 for the deviation. Compass heading for leg 2 is going to be approximately 184. So we determined that our ground speed for that first leg was going to be 116 knots. I've already placed the 60 index under 116. Our leg distance for that first leg is going to be 44 nautical miles. So again, on the A scale, we come around until we find 44. We move inwards to the B scale. So we can see that in that case, look at about 22.9. We'll just go ahead and call it an even 23 minutes. So for our leg 2 time, we're looking at 23 minutes. Now we can go ahead and calculate the fuel for leg 1 if we wanted to. We're going to go ahead and assume that our fuel burn is still going to be that 8 gallons an hour. So in that case, we're going to move our 60 index over to that 8. Now because we're using 23 minutes, first we're going to come into the B scale and then move out to the A scale. So if we find the 23 minutes, we come out, we can see the fuel burn is going to be approximately 3.05, or we'll round up and call the fuel for leg 1 3.1 gallons. We'll do the same calculation for leg 2. We'll go and park that 60 index on our 120. Our distance for leg 2, hey, look at that, is 44 nautical miles again. We'll come into the B scale and we can get our distance, our leg 2 time. We're looking at 22 minutes. Just like we did the fuel calculation there, we'll go ahead and park that reference on the 8. Come in on the B scale, find our 22 minutes, come out again. We can see that we're looking at about 2.91 gallons. We'll go ahead and round it up and say that a leg 2 fuel is going to be 3.0 gallons. All right, now let's do some addition here. We want to know what our total distance is going to be. So we'll just take our distance from leg 1, we'll add it to the distance to leg 2. So we've got 44 nautical miles and 44 nautical miles. So our total distance is going to be 88 nautical miles. Same thing with the time. We can see our leg 1 time, looking at 23 minutes. Our leg 2 time is going to be 22 minutes. Add the two together for a total time of 45 minutes. All right, let's take a look at our fuels. Our leg 1 fuel is 3.1 gallons. Our leg 2 fuel is 3.0 gallons, which gives us a total en route fuel of 6.1 gallons. We still need that VFR reserve. So day VFR, that's going to be 30 minutes of reserve, or half an hour. At 8 gallons an hour, that gives us 4 gallons of reserve fuel. So our total fuel required for this route with those VFR reserves, we're looking at 10.1 gallons total fuel. So that takes care of the lecture for today, guys, for the Wednesday. So first YouTube style lecture, we'll see how it works out here. Now I did mention there would be some review questions for today. What I'm going to do is I'm just going to go ahead and read them and have you all answer them. So just go ahead and type them up on a Word document or send them to me in an email. Send it to me. These are going to be due by the end of the day on Thursday for everybody, all right? So question 1 is, what do I reference on a sectional chart to determine my magnetic variation? All right, we referred to it several times during this particular lecture. So tell me what I need to refer to on a sectional chart to determine the magnetic variation. All right, question 2 for you is going to be, suppose that you do find that item that you referenced to give you the magnetic variation, and it reads 5 degrees east. All right, is that 5 degrees going to be subtracted or added for easterly variation? And the last question I have for you guys today is a sectional chart oriented to true north, magnetic north, or grid north? All right. Again, answer those questions either in a Word document or an email. Get them to me by close of business on Thursday, and that will be your homework assignment for the week. I would encourage everybody to go ahead and work through these calculations on your own. Try a couple different iterations of them and see if you can come up with consistently correct answers. Otherwise, that's it for today. Stay tuned. I'll be sending out an announcement via email as far as when the next actual lecture is going to be released. All right. Thanks for your attention, everybody.